Division. The top has to be F. The bottom has to be G. That is not optional. Okay? The other thing is, it's written as G, the derivative of F minus F, the derivative of G over G squared. The way I write it in short form, good, I'm still not adapting, so that's good, I've insisted. F over G prime equals GF prime, which is why I made you write the product rule in this form. It's GF prime minus FG prime, so the only difference is there's a minus sign between them, and you have a G squared on the bottom. So it doesn't make it that much more crazy. It's still the same things. You still have to take the GCF out the same way. You just happen to have a denominator of G squared, right? And that little subtraction sign that has to distribute through. That's the only big difference. So that's why I wanted to push you guys doing your product rule on reducing better. So for this one, we have a polynomial over a polynomial. It wants us to differentiate y equals x squared plus x minus 2 over x cubed plus 6. So this is my f. This is my g. I will always find f prime and reduce it as much as I can. Find g prime, reduce it as much as I can. Okay? So f prime is 2x plus 1. Using power rule, 2 drops in front, x becomes a 1, and the 2 minus 2 goes away. Can I reduce that at all? Can I take out any GCFs? No, so that is f prime. If I could take out a 2 or I could take out an x, I will do that here so that I don't have to do it throughout my actual quotient. G prime is 3x squared, and then the 6 goes away. So we still follow all the same things. So this is y. I need y prime. And I'm going to get, oh my goodness, g, I'm putting myself to sleep, so that's good, x cubed plus 6 times f prime, which is 2x plus 1, minus f times g prime, all over g squared. Now, a lot of people will accidentally drop off the bottom, or they'll forget to square the bottom. That happens, oopsie, not like actual mathematical problems. So when your numerator is a polynomial and your denominator is a polynomial, or in power rule, both of them are polynomials, they make more like work, but they're easier to do because there's no GCFs to take out. You're literally going to distribute, collect like that. That's it. So you should be joyous when you see polynomials on both the f and the g. So we're going to distribute these out. So it's a little more work, but it's not hard work. So x cubed times 2x, I get 2x to the 4. X cubed times 1, x cubed. 6 times 2x, 12x. 6 times 1, 6. Minus x squared times 3x squared is 3x to the 4. Now you can either carry the minus sign through in one step here, or you can go minus in brackets and then distribute the minus sign through. Whatever you don't make oopsies with is good. Bless you. Then x times 3x squared is 3x cubed, but there's a minus sign, so it's minus 3x cubed. And then negative 2 times 3x squared is minus 6x squared. Minus and minus is plus 6x squared. All over x cubed plus 6 all squared. What's left? What do we have to do? The bottom will stay, because if we actually have to distribute it out, we wouldn't be simplifying, we'd be expanding. But what we can do is we can collect like terms on the top, right? So we get 2x4 minus 3x4 is negative 1, x to the 4. X cubed minus 3x cubed is negative 2x cubed. plus 6x squared alone plus 12x plus 6. There's not an x I can take out. There's not a number I can take out. It's as good as it gets. There's no GCF. And the bottom is x cubed plus 6 squared. Benito. Yeah. The next one has an e to the x in it. E to the x's I actually enjoy, because an e to the x just gets me e to the x, and I know the GCF and e to the x out. That's not a complicated one, right? When they're to like the negative a half and stuff like that, that's when it gets complicated. To the halves, those are the harder ones for us right now. So this one has an e to the x and a polynomial. Easy. It gets hard when you have roots, because that's when you get to those fractional exponents, right? Okay. So I want you guys to try this one out. This is f. This is g to f g prime. And then just get m tangent. So just get the derivative for now. And then we'll carry on. So this, Doctor, if you have time, keep going, but we're going to stop at the derivative. So f prime is e to the x. G prime is 2x. I want to show you something. So most people don't struggle at filling in g f prime minus f g prime over g squared, right? Even in product rule, filling in the product rule was not the struggle. The struggle was trying to get it to be in the lowest, like to go to GCFs and all that stuff, right? If ever you're doing tangent lines, just fill in the quotient rule and fill in 1 and call it a day. Why would you ever GCF or simplify it? You're filling in a number for all the x's and getting an answer, correct? If you go to the next step and start even taking out an e to the x, you could possibly be making a mistake. So if it's a tangent, I don't even simplify. I just go m tangent. I write out my quotient rule. So I go g f prime minus f g prime over g squared. And that's the general tangent. If they want a general tangent, I would have to take the e to the x out. I would have to distribute through class-like terms, call it a day. They don't want general tangent. They want the tangent. Correct? What does x equal? 1. Fill it in. Don't simplify it, right? You fill it into the formula and put in your x's right away. So I'm going to get 1 plus 1 squared e to the 1 minus e to the 1, 2 times 1 over 1 plus 1 squared. Don't forget the squared on the bottom. E to the 1s are just e's. You can't make them better. E to the 0 is 1. E to the 1 is 2.718, blah, 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 blah. Don't put it rounded decimal. So we're going to get 1 plus 1, which is 2e minus, what happens? 2e minus 2e over 2 squared, which is 4. What's 2e minus 2e?
0.
Can I do 0 divided by 4? Can I do 4 divided by 0? No, that would be an undefined slope, so it wouldn't exist. 0 divided by 4 is 0. Can I have a tangent slope of 0? When do I have tangent slopes at 0? Maximum, minimum points of inflection, or that curving point. So I'm guessing on this graph, 1 and 1/2 e is probably a minimum or a maximum or a curving point, right? So how would I write up my equation? My x is 1, my half e is y, and so I would get y minus 1/2 e equals 0, x minus 1. What's 0 times anything? This whole side turns to a 0, right? So I get y 1/2 e equals 0. You could leave it like that, or you could write it as 1/2 e. It's just a horizontal line. People don't spot that 1/2 e is a horizontal line. 1/2 e is a horizontal line. It's half of e. So 2.71 divided by half. So it's 1.3 blah, blah, blah. There's a horizontal line at 1.3 blah, blah, blah on that graph.
Oh, yeah,
Because e is just a number, right? And horizontal lines are y equals 7, y equals 4, y equals 3, y equals half of e. Okay? Everyone have that? So it's at the bottom of your page. It says, don't use the quotient rule every time you see a quotient. Sometimes it's easier to rewrite the quotient first, put it in a form that's simpler for the purpose of differentiation. Often done when the denominator is a monomial. We've already talked about this. So remember I told you sometimes something looks like a product rule. When it's a polynomial, it's a polynomial, and I told you the fastest way to do that is not product rule. The fastest way to do that is FOIL it, and then do power rule. We agree? These ones look like quotient rule. They screen quotient rule too, because there's a F and there's a G, right? That is not the fastest way to do this. Remember, if it's a quotient rule, you're going G times F prime minus F times G prime all over G squared. That's not quick. If I was like, hey, do something quickly, I would not pick quotient rule. I would be like, oh, that's quick. It's not. Okay? So, if you don't spot this every single time, you will do quotient rule with this every single time. What's in my denominator? A monomial. A monomial. One term, just an x. Correct? Yeah. When you have a monomial variable, so like x, x to the half, x to the 2, x to the 7, 2x to the 5, any of those, when you have monomials, what you guys forget is that you can split them up as separate fractions. So for example, side note, if I gave you x over 2 plus x squared over 2 minus x cubed over 2, you'd say, oh, they're all over 2, Mrs. Lepp. I can just write it as x plus x squared minus x cubed over 2. You would tell me that, yes? Everyone's really good with knowing the rule going this way. Everyone's very forgetful realizing the rule can actually go that way. So anytime you have something over a monomial, you can actually write every single term separately over that monomial, can you not? Instead of going from common denominator and writing it as 1, you can actually have it as one denominator and write it as a whole bunch. So whenever I get a monomial, I say, thanks for trying to trick me here, but I'm going to do not quotient rule. So I have f of x equals, first off, I'll just rewrite this so I don't lose people, 3x squared plus 2x to the what? 1/2. And it would be all over x technically, yes? But can I not just do this? Can I write them separately over x? Because if they're separately over x, could I not write them all together over 1x? Common denominator of x. So everyone's really good at remembering when I have common denominators put together as one fraction. Everyone's brutal at remembering that you can pull them apart. So you have to think, whenever I have a denominator that's a monomial, I need to write them each over it, power rule, not quotient rule at all. Okay? So it looks like a quotient rule. You do not need to do it that way. So I still have f of x. I didn't do any derivatives. I just wrote it over x. I still have f of x. I'm going to put these together now. Right? What's 3x squared divided by x to the 1? I have same base division. What do I do with the exponents? Subtract. So what's x squared minus x1? X. We agree? Now this one, what's x to the half over x to the 1? A half minus 1. What do we get? Negative a half. So we're getting 2x to the negative a half. And then some people will box this and say I'm done. Have I derived anything? No, I just wrote it in a different form that I can now do powers. The forms get me all the time. I can do power rule with this now, right? So here's my power rule. F prime of x equals, what's the derivative of 3x? 3. And then what's the derivative of 2x to the negative a half? Negative a half drops in front, multiplies by 2. What's negative a half times 2? I won't skip it. I'll just write it out because I'm losing. 2 over 1. X to the what? What's that? Negative a half minus another 1. Negative 3 over 2. If you want to think about it as in decimals, you can and then convert. What's negative 0.5 minus 1? Negative 1.5, which is negative 3 over 2. Yes? Okay, so we get 3 plus, what's negative 2 over 2? negative 1. So I don't need a plus sign. So it's negative 1, x to the negative 3 halves. If they make if they make positive fractions, they might rewrite it as 3 minus 1 over x to the 3 halves, positive. And they might write it as a radical. How do I convert x to the 3 halves as a radical? Square root of x cubed. Yeah. This index pops in, this number on the bottom is my index, pops under, the exponent at the top stays the exponent. So this would be 3 minus 1 over the square root of x cubed. We agree? So this is equally as right, this one here, as this one here, as this one here. Which one's the most correct? It's the multiple choice one, it matches. If it's your answer key, the one it matches. If it's written response, any of those three gets full marks. Okay? So we're going to start working on homework together. We're going to try number 5 first. This is all going to be homework, but we're going to work through it together. Just instead of giving you a whole bunch of more examples, I figured we could do a little homework work together. So page 189, number 5, we'll do first. I will be posting this one to Google Classroom first in a while. This is number 5. Try it out. All right. You can keep going if you haven't finished. You can compare it at the end. F prime is 1. G prime is e to the x ln e times 1. So it's just e to the x, right? So y prime is g f prime minus f g prime all over g squared. Don't forget to put the square. So what can I take out of the numerator? E to the x. When I take an e to the x out of, okay, whatever. E to the x out of e to the x 1, I get 1 minus e to the x out of x e to the x. I'm left with a x. And what do I do when I have an exponent and another exponent side by side with a bracket in between? Multiply. So I get e to the 2x. Actually, no. I'm going to make it better. Check that. If I have e to the x squared, what can I do if I take this out? Cancel, cancel, right? 1 for 1. So I'll get y prime equals 1 minus x over e to the x. Number 7 is a polynomial over a polynomial. What are we going to do? Polynomial over polynomial. We do it just like we normally do. Will we be able to take out GCFs? No, we will just distribute after we do our quotient rule. Like church, right? Try it out. So we have f, g, f prime is 2, g prime is negative 4. So we get g prime of x equals g times f prime minus f times g prime. In this case, you could have taken a 2 out if you so chose, but I'm just going to do that at the end because it's just a number, and taking out a GCF of a number is often easier if there's something out of all the terms. Okay, quiet please. So, we distribute and we get 6 minus 8x, and then 1 times negative 4 is negative 4, but there's a minus sign, so plus 4. 2 times negative 4 is negative 8, which is a minus sign, so plus 8 x all over 3 minus 4x squared. These cancel. I'm left with 10 over 3 minus 4x. All squared. Okay, next one, 13. I'm going to write 13 and 15 on the board. So here we have f prime is 3x squared, g prime is negative 2x, y prime equals g times f prime minus f times g prime all over g squared. So we get y prime equals 3x squared minus 3x to the 4 plus 2x to the 4 all over 1 minus x squared squared. Collect like terms, so I wrote 4 instead of 2. Nope, that was stupid. It was right. 3x squared. Okay, so negative 3x4 plus 2x4 is negative x to the 4 plus 3x squared. Is there anything I could take out in the numerator? X squared. And we will want to take that out for critical numbers for the next unit. Because critical numbers will give us our max, mins, points of inflection. Where they exist. Okay. 15. We have F, G. F prime is 2t. G prime equals 4t cubed minus 6t. So y prime equals g times f prime minus f times g prime all over g squared. Now what I get people trying to do is just cancel one of these t to the 4s off. You can't do that, right? It's full term, full term. The only way you can cancel it off is if you GCF it out. If it's polynomials, there's no GCFing out anyways. You're just distributing. So y prime equals 2t to the 5 minus 6t cubed plus 2t. T squared plus 4t cubed is minus 4t to the 5. Then I get minus 6t cubed and negative, so plus 6t cubed. 8t cubed with a negative sign in front, so negative 8t cubed. Minus 12t with a minus sign is plus 12t. All over t to the 4 minus 3t squared plus 1 squared. So y prime equals 2 minus 4 is negative 2t to the 5. Those cubes cancel, so I'm left with negative 8t cubed. 2t plus 12t is plus 14t. Is there anything I can take out of the top? T and a 2. I'm going to take a negative out because I don't like having a negative leading coefficient. If you took out just positives matter. I'm going to take out a negative 2t, and I'm going to be left with t to the 4 plus 4t squared minus 7 all over t to the 4 minus 3t squared plus 1 all squared. Okay, then we have 19 and 21. Not polynomials. This one has roots in it. 19. Y equals v cubed minus 2v root v over v. Should we leave it as 2v root v? We've talked about this before. Or should we put those together? Put them together. So I'm going to get y equals v cubed minus 2v times v to the half over V, correct? And then I'm going to put those together. When you multiply same bases, same exponents, what do you do with the exponents? Add them. Not same exponents, same base. So V cubed minus 2V to the, what's 1 plus a half? 3 halves over V. The denominator is a monomial. Should we do quotient rule?
Yeah.
No, we should split each one of them over V. So do that. Try that. This one you have to do quotient rule with because there's a binomial in the denominator.